Colin Smith, and today I'm going to be showing you how to complete a calculus word problem using the quality rep format. Alright, let's get started. So the problem we're going to be doing this afternoon is primarily going to involve the fundamental theorem of calculus parts 1 and 2. It's an optimization problem, and our problem statement says water flows from the bottom of a storage tank at a rate of R of t is equal to 200 minus 4 times t liters per minute, where t is greater than or equal to 0 and less than or equal to 50. We need to find the amount of water that flows from the tank during the first 10 minutes. One of the most important steps of the quality rep format is the assumption step. This is extremely important because what we assume here is going to determine how we approach the problem from this point onward. For our purposes, it can be assumed that water is not added to the tank between 0 and 50 minutes. This assumption is reasonable because it makes sense within the context of the problem. It's also necessary because any change to the original amount of water in the tank after time has been started will interfere with our use of integrals and antiderivatives. The next step in the process is the formulation step. In our formulation, we're going to determine the variables and the equations that we're going to use for the problem, and we're going to define both of them. For our purposes, we are defining R of t as the rate at which water flows out of the tank in liters per minute at a specific time t. That can also be defined below as R of t is equal to 200 minus 4t. That's the same equation that was given to us in the problem statement. We're also going to define t as being equal to time in minutes, and we're going to define S of t as being equal to the amount of water that exits the tank in liters at a specific time t. Next, we're going to complete the methodology step. For methodology, we are essentially going to explain how we're going to tackle the problem ahead of us. For our question, we've been asked to find the amount of water that flows from the water tank during the first 10 minutes of a time period that spans from 0 to 50 minutes. In order to do that, the very first thing we're going to do is set up a definite integral. The reason we're doing this is because the net change theorem, which is explained on page 410 of the Stewart text, explains that we will be able to determine the amount of water in the tank at any specific time by taking the antiderivative of that function. In order to take the antiderivative, we're going to be using antiderivative rules that are found on reference page 6 of the Stewart text. Alright, now that we've made our assumptions, defined our equations and variables, and explained our methodology, we are ready to get cracking and find some results. So here I have set up the equation we discussed in our methodology. I have S of t, which is the amount of water that leaves after a certain time, equal to the integral from 0 to 10 of 200 minus 4 times t dt. And all we're going to do is use simple antiderivative rules to find the integral of this function. So we know that the integral of a constant is just that constant times the variable. So in this case, that'd be 200t. We also know that the integral of 4t is going to be t squared times 4 divided by 2 is 2. And again, this is being evaluated from 0 to 10. Next, we're going to substitute these values back into the equation, each, subtract them from each other, and we should get an answer. So we'll do 200 times 10 minus 2 times 10 squared. Take that whole big thing and subtract 200 times 0 minus 2 times 0 squared. Now this whole big thing right here obviously equals 0. This is going to be equal to 2,000 minus 10 squared is 100. 2 times 100 is 200. 2,000 minus 200 is going to be 1,800. So by solving this integral, we know that between 0 and 10 minutes, 1,800 liters escaped from the tank.